All right, we didn't quite make it through the video in one shot. So, my daughter's cat was meowing out the door, and I just wanted to make sure he was all right. I think he saw a fly or something like that in the house. All right, so we're going to kind of sketch this and see what it looks like. What is our y-intercept? Well, that's going to be 96 because that's our c value. It's going to go up in the air and then it comes down. And I know it goes up in the air because it has a positive b value. And then it comes down and hits the ground. Here's the ground right here. The other x-intercept is going to be a negative somewhere. The initial height, easy enough. 96, baby, right here. That's the starting height. That's our c value. All right, let's do a little labeling. A, negative 16. B, 80. C, 96. All right. B. How long does it take for the rocket to reach its maximum height? The maximum height is here. How long does it take is the x. The x is the same as the axis of symmetry. So we're going to do negative b over 2a, or the opposite of b, over 2a, minus 80 divided by 2 times negative 16. That's negative 80 divided by negative 32, and that is going to be 2.5, and that's going to be seconds. How long does it take for the rocket to hit the ground? Actually, I guess we'll do C. What is the maximum height? Well, we take that 2.5 and we're looking for the y now. We are looking for the y of the vertex. That's going to be the maximum height. So we're going to do negative 16 parentheses 2.5 close parentheses squared plus 80 parentheses 2.5 close parentheses plus 96. I'm going to let you guys do that one since I don't have the calculator right next to me. How long does it take for the rocket to hit the ground? This time we are doing a big red X, negative 16x squared plus 80x plus 96. Divide by negative 16, and we're going to get x squared. That's going to be minus 5x minus 6. So two numbers that multiply to negative 6 and add to negative 5. It's going to be negative 6 and positive 1. The opposites of these are going to be our answers. X equals negative 1. That's going to be right over here. And x is going to be a positive 6, which that is supposed to be a 6. X equals 6. We only care about the positive one. It's going to be 6 seconds when it hits the ground. All right. Desmos active. Woof, we like that, don't we? All right. So we're looking here. And actually, I guess since it says Desmos active, we can go to Desmos and we'll plug in what we need to plug in. And we have negative x squared plus 2x plus 8. Okay. All right, so the maximum height for Jody is somewhere. Let me get the maximum height for Jody. Looks like it's, I would say, 5. It's going to be. Looks like it's going to be 5 feet right here. When does Jody balloon hit the ground? That's going to be right here at 10 seconds. A. Dawn's maximum height. Let's go to that. Desmos. Here's the maximum height. and it's the y value, which is the height. So that's going to be 9 feet. When does Dawn's balloon hit the ground? That's going to be right here, and that's going to be 4 seconds. Mackenzie's maximum height. Well, with this one, you can't put it in Desmos, but you do have to pick out the vertex. Okay, and if I would sketch a little graph here, if you sketch a little graph, if I asked you what the y-intercept was, you would pick out the one that has 0 as the x, and that's 0, 3. That's your y-intercept. So this point right here is your y-intercept, 0, 3. If I said, what's the x-intercepts, you would say -1 and also 3 over here. So this, if we sketch it, is going to look like this. This comes down to -1, and it will go up in the air a little bit, and then it'll come down over here. And when you see how this 1, 4 is smushed in between the 3 and the 3 on the y's. Let me erase the x's so you can see that pretty clear. Okay. You see how there's a number 4 that's smushed in between the two 3's, and then after that it branches out and things are the same on the y, 0, 0. This is -5. On the other side, it would be -5 also. It would be 4, -5. When you see this 1, 4 that's right smushed in the middle, surrounded, it's sandwiched. The 3 is the bread and the 4 is the meat right in between. That is going to be your vertex. Okay, it's also going to be your highest point. All right. So Mackenzie's maximum height here is the vertex, and that's going to be 4 feet here. When does Mackenzie's balloon hit the ground? That's going to be at 3 seconds. Okay. Whose balloon went the highest? That's going to be the maximum height. All right. We had Jody's balloon was 5. Dawn's is 9. So that would be Dawn. And then whose balloon was in the air the longest? And that is going to be Jody, because Jody's was in the air. It took 10 seconds. That would be Jody. All right, hope that made sense. All right, given this table, y-intercept. Anytime we have a y-intercept, we know the x equals 0. Here's the x, 0. So that is going to be our y-intercept. 0, comma, -3. X-intercepts is when the y equals 0. So our x-intercepts is right here and right here. So x-intercepts, we actually have 2 of them. And we're going to do -1, 0, and 3, 0. Let me make that 3 a little nicer. Make 3 like that. Wow, that's an ugly 3, but I'm going to leave it. All right, the vertex. Where are we smushed? Okay, let me erase here and see where the meat and the sandwich is. Where's the bread of the sandwich? Oh, I see the bread. -3, -3, and then the meat is this right here. That -4 is in between. That means it's the vertex. That 1, -4 is going to be our vertex. All right. Factored form of the quadratic equation. Man, all right. We didn't go over this too much, but all right. So the factored form of the quadratic equation is going to be, all right, the opposite of your x-intercepts. So it's going to be 1, 0, okay? Or I should not say that. It's going to be x plus 1. It's going to be the opposite of this, and it's going to be x minus 3. I took the opposite of this, and I took the opposite of this. The standard form is if we multiplied these together. If we FOIL this, x times x, x squared. X times -3, -3x, plus 1x minus 3. And I'm going to combine the middle, x squared minus 2x minus 3 and that equals 0. Okay, or we can put y equals at the front. All right, got a couple more here. Given this equation, complete the chart. Does it open up or down? Because there's a positive in front here, I know it opens up. When it opens up, I have a minimum. Axis of symmetry. Let's do our a equals 1, because that's the number in front of the x squared. B is negative 2, and C is going to be a negative 8. Opposite of B is going to be a positive 2, divided by 2 times 1, which is 2. Axis of symmetry is x equals 1. Make sure you put an x equals with it. To get the vertex, that means we have to, that's going to be 1 squared, because we're taking this right here and replacing every x with a 1, minus 2 times 1 minus 8. I'll let you guys do the work on that. X-intercepts, I think you can do Desmos on this, but if you can't, we're looking for two numbers that multiply to negative 8 and subtract to negative 2. It's going to be negative 4 and positive 2. The opposites of these are your x-intercepts. So it's going to be 4, 0, and it's going to be negative 2, 0. And I guess they want us to sketch this graph right here. All right, we know our y-intercept is negative 8. Okay, we know our x-intercepts are 4 and negative 2, and positive 4 over here. And I guess I got to figure this out. That was 1 minus 2 minus 8. That's going to be a negative 9. 1 minus 2 is negative 1. Negative 1 minus 8 is negative 9. So our vertex is going to be 1 comma negative 9. I got the 1 from here. I plugged it in. I got negative 9. So 1, negative 9 is here. Sketch the graph. Okay. Domain. Every single time. Rangy. Y. The arrows are going up, greater than or equal to. And whatever the y of the vertex is, the y of this vertex is negative 9. Increasing. Okay, increasing and decreasing. We always do x and whatever the axis of symmetry is. Then, if we're coming in from the left side, this is the less than side, this is the greater than. We decrease when it's less than, decrease is less than, and we increase when it's greater than. We're increasing when it's greater than. Positive, the hump. Oh, where's my hump? It's been a while since I had the hump. Okay, the hump is negative here. See how the hump is negative? So the negative is going to get the in-between treatment. And you're going to use your x-intercepts, negative 2, positive 4. And then here we're just going to separate them. X is less than negative 2. X is greater than 4. All right, brought back the hump. All right, numbers 19 and 20. All right, we can use Desmos with these. 16, 40, 50. Let me get that into Desmos. So let's see what we can do here to answer these questions. And the questions are the maximum height and when did the performer reach the maximum height. So that's going to be the same point. One's going to be the x, one's going to be the y. The maximum height is the y, 75. And the time that it got to its maximum height is 1.25. Now, when did the performer hit the ground? That is going to be over here at 3.415. Okay. Number 20. Negative 3.75. And we're going to use x squared all the time. Negative 3.75. All right, let's see what the next one is. And that's going to be 23.2 and 38.8. 23.2, 38.8. All right, and what are they asking? I'm sure they're going to want to see how high it can go and when it hits the ground. That's usually what they ask us here. All right, so they're going to ask us find the engine speed that maxes torque. All right, S stands for speed, and that's our X. So we know if they're asking about the speed, our answer is going to be X. So the engine speed is going to be that maximizes it is the maximum here, and it's the X, 3.093. The maximum torque is going to be the Y. The Y is the torque, 74.683. And the initial torque or the starting torque, we can just get that from here actually, and that's going to be 38.8. All right. I hope you guys had as much fun as I did. And see ya.